This video is for functions. So before we can define what a function is, first we have an ordered pair, and that was our ordered pair. Remember, it's alphabetically ordered pair of numbers. It's your x comma y. And a relation is a set of ordered pairs. So these are all relations. Okay? So functions are a special type of relation. It's a relation where for every x value there is one and only one y value. So what that means is if you have an x value and you input it into an equation, it gives you one and only one y value. So that means we have basically no repeating x values. And that's good enough for us right now until we really understand what a function is. So if you look at these relations, you can determine if they're functions based on the x's. Do we have repeating x's? No, then that is a function. Do we have repeating x's? Yes, right here. This is not a function. Repeating x's? Nope. Function. And it's that simple. Right? So if you look at a graph, the way you can tell is by drawing vertical lines. If you draw a vertical line and that line hits the graph more than once, this is not a function, because what we're getting is that repeating x value. If you find 2 points right there, that point would be -3, 4. And if you follow it straight down, we also have -3, -3. You see the repeating x? So if you draw vertical lines and each vertical line goes through the graph one and only one time, then it's a function, like on this one. One time, one time, one time, one time, one time, function. But if you can draw a line and it goes through more than once, twice, 3 times, it's not a function. Alright? So here is what you get if a equation is a function. You get this little formula. And what we do is we write it like this. It's f of x. This doesn't mean f times x. It means the value of f at x, or the value of f for that x value. So what you're going to do is replace that x value with numbers, and you're going to plug it in. So the way we start it is to first put a parenthesis for each x. This allows us to maintain our order of operations. Okay, so we're going to do that for each one. Since they're all f, we're just going to write the parentheses and just keep transferring it down. If you always start your function this way, you won't have any confusion when you enter the value of x. Okay, so there we go. If you need more time, just hit pause. Alright, now we're going to plug them in. So here, these are our x values. It's f of x. So our x here is 1. So you just plug a 1 into the parenthesis and simplify. So 1 squared plus 2 minus 4. That's 3 minus 4 is minus 1. That's all you have to do. So try the next two. Hit pause. See if you can find out the value of f when x is 3 and the value of f when x is -5. So you should have gotten 11 for both. And if you see these two, that's what you get. So f of 1 is -1. F of 3 is 11. F of -5 is 11. If you think, oh, we got a repeater. No. Remember, it's the x's cannot repeat. And here's the reason that you can see that there's no repetition. Each time we plug in an x value, it gives us 1y. We're never going to be able to plug in 3 and then get 2 different y values. Right? You're not going to plug in 3 and get an 11 and then plug in 3 again and get a 12. It's not going to happen. You get 11, period. So that repetition right here is not going to happen with a function. See? You plug in 3, you get one number. One and only y. And that's where the definition comes from. It's for every x value there is one and only one y value. So for that x, you get 1y, period. You're not going to have 1x and 2 different y values for that same x value. So no repetition. All right? So what if you have an apple? Well, you just plug in an apple. What if you have a squiggly line? You plug in a squiggly line. It doesn't matter. Whatever you have value-wise here, you just plug it in. That's it, okay? Alright, so just a little bit more on them. So if this equation is a function, then you can write it as a function. F of x equals negative 2x plus 5. And when you do that, f of 2, and it gives you 1 by plugging it in, this right here is your ordered pair. That's why this is a relation. It's a set of ordered pairs. It's an infinite number. So you get x comma y is 2 comma 1. So this is x and this is y. Your f of x and your y are the same if it's a function. So write f of 3 equals 7 as an ordered pair. So again, that's your x, that's your y. So it would be 3 comma 7. How would you write this as a function? You take the y and you replace it with f of x. And now it's a function. And that's functions.